classical localization theory, we couldn't prove it in our context. So it's homework, I guess. Have an idea, let us know, or don't let us know. But it turns out that phi is omega localization, if and only if phi is an omega isomorphism, and k is omega local.
So this is a conjecture?
It is a conjecture. It is something we believe, yeah, call it a conjecture.
We believe it's true.
We believe it's true.
It's similar to the diagram you...
It's similar to this, so let's do more. Let's try to go further. It is a conjecture, I guess, not a problem. Another problem, which is, this is a problem, right? So let's see if you can do it. Find two groups in this category, nilpotent or power groups. Yes, question.
Yeah, no, I was just thinking of when you were taking your localization. I just answered my own question.
Okay. So try to see if you can come up with some kind of a generalized Remeslenikov example, or maybe we can come up with, or anybody can come up with.
So you said P, if you insert 2, 3, you get PQ, it's going to...
But now take primes, let's say, in Q square bracket X. So take primes in a ring which is not Z. Think about your nilpotent or power groups, and can you find two groups in this category for some particular R, which are pi isomorphic for every prime, but not R isomorphic? We think this can be done.
I guess what I was trying to say, since you're generalizing this this GP, where your P's per prime, to the property of omega localization, you can also try to work in residually localization properties. Have you looked into that? In the context?
Not yet. Residual localization properties?
I mean,
what do you mean?
Instead of looking at one specific kind of one-to-oneness, you look at finite sets, or am I confusing the definition? You are looking at finite sets.
Well, in this case, pi is just one prime.
Yes.
Pi is just one prime.
Yes.
But maybe you can take a finite set of primes.
I'm just confusing one definition with the other.
Actually, it does say for every prime. So you can take. I guess I didn't show it in the slide, but you can take pi to be one prime. What is a prime in Q square bracket X? I don't know. Think of a prime. Anyway, take one prime and just try to show that these groups are pi isomorphic for every prime, but not isomorphic. Okay, and so that's Jesse Elliott's result. So we suspect that the following is true, that G is omega local, then G is an nilpotent or omega power group always. And we just couldn't get the axioms to work. Thank you very much.
Any more questions?
Like you mentioned before, residualness requires unrestricted direct product or just subdirect product?
Well, a group is residually P,
I'm trying to remember.
if and only if it is a subdirect product.
Yeah. So we don't need it unrestricted, do we?
I think, doesn't a subdirect product embed in a direct product?
That's
my...
No, that's
I think you need an unrestricted direct product.
You need unrestricted. Well, unrestricted just means that, what does it mean exactly?
That
Also
you're out
depends on the
have
property.
infinite entries.
what kind of inheritance.
Yeah, but that's okay. I think you can show that an unrestricted direct product of omega things is an omega thing.
I think there's a theorem in universal algebra which says that things that behave this way are also close under products, and that they're close under direct limits and all this kind of stuff. So that will give you this close under that, then it's close under, unrestricted direct products. Make, for example, say you have those very ultra products.
Right.
So definitely, you can tell that that's really large, and then just taking regular products.
So we need to look into that carefully. But I think it's.
Well, what I found very interesting with this whole paper, and I remember we were talking about this, is the fact that residualness even came into localization. Because in the classical proofs, they never mentioned that residuality stuff, and the fact that we generalized Grunberg's theorem and that was used to do this,
That was really the key.
I found that pretty nice.
Yeah, if you read the monograph on localization, there's really not. I mean, there's nothing about it where, you know, residual properties are not used, and so yeah, it's nice.
Any other question?
With residually, being residually finite, I'm just forgetting to mention really quickly. So you pick in a set of elements, correct? It's not like one specific element.
Residually
You
finite?
would take a
Right.
set of
You
five.
take a set, yeah. This one.
That's-
Because my problem is
It's a
this.
different name, but.
Yeah.
Right, because when you look at the category here, that you have your HP objects, you know, you have whatever, countable number of categories that look like that. But when you restrict to this, you collapse everything into one specific category. Like you don't have, when you were working before, with many different structures, now you collapse everything into one. So maybe there will be a way of like splitting this into, instead of talking about omega residual, you can say, well, I'm going to look only at the objects that are only, say, length 10, length residually up to 10 elements, residually up to 13 elements, residually up to 17 elements, something like that. Be interesting. Might get.
Sure.
Okay, so let's thank Marcos, but before that, we're going to go upstairs for lunch. Everyone's welcome.
We're not gonna thank him yet?
And
Before
Not
we
yet.
thank them.
And also next week, Ben Fine is going to speak about password security using combinatorial group theory. So let's thank the speaker.